Hello, today we have something really interesting. I've been working on this. Uh, so it's lesson 3, input and output. In Python, every program does three things. It works on the input, then it processes it and gives you the output. The input is how information gets into your program. The output is the results that get out of it. So the input in machine learning is usually a data set. The output is most likely the predictions. Let's see here. So 3.1 input from the keyboard. The simplest input that you can get is ask a person running the program to type something. For example, here, the input function. Python waits for you to type your name and then press enter. Okay. And then in the output, you print the final result. Let's see how this works, what you would expect. For example, name input will be something like write your name. And it opens a window and you write your name or the answer that you want. Okay. On the second, then you print the result, which will be your name. It will appear your input. You already know we have here the code, the results, the comments, and then you can practice here. On the right, it's the ideal thing for you to learn. Important, the input always gives you a string, even if you type a number. If you want to do mathematical operations with what you type, with your number, you must convert it to an integer or a floating point number. In chapter 1, we saw this, how we do it, okay, with the instruction int or float. Let's try it. What would happen if you type your age and you print, you sum the age, you'll get 5050, which is really not what you want. So basically the strings get glued together and this is not what you want. But let's try it right here. Age input. Let's just do it like this. We can write 25 now. Okay. And if we print the sum of age plus age, we'll see that it's not a mathematical operation. This is not what you want. We first have to convert it into an integer, the age, in order to do then the mathematical operations. So basically, age okay. I didn't have it here, but we can try it right now. Age plus age 50. This is what you wanted. Okay. So the output we print your age is, we have the number that we inserted, 50 in this case, years old, and you have the output. Okay. This will be something like you have to write a comma, our variable, another comma, and then years old, and it prints what you want. And let's now go into this. If we want to convert something, if we want something that is a floating point, we convert using float, and you ask this input. Okay. This will be right here. Let's test it. 8. We convert into a float. We ask for the input. And now it can be this. We don't need this. 1.75. And now we have a floating point number. Okay. here we have the answer. We can ask it right here, which will be, hey, no, let's just undo this. If we need to undo, just go undo typing. So we print the answer, which will be whoa, comma, 8 years, not years old here. It will be meters. This will be in meters. And we can also do it using f-strings, which we already saw on the basics are the more readable and commonly used today. We have the variable name, we have the variable age, and we put it inside these brackets with an f, indicating that it is an f-string indeed. And let's try it right here. F hello. Where we have this f-string. Sorry, I'm not finding here. Okay. Okay. You are years old. Okay, and it works. We have the name using the f-string indicated right here, and when with these brackets, we have the name and we have the age. Okay, so now let's go for where is my file. Before reading a file, Python has to find it. Python always works inside one folder, which is called the current working directory, which is where your files are. When you write, for example, data.txt, Python looks for that file in that folder and nowhere else in the computer. This is the reason for the most common problem when starting a data science project, which is file not found error. Usually the file exists, you put it there or somewhere, just not where Python is working. So, if you want to get the current working directory, you import this package, you get from this library, you use get current working directory, cwd, okay, and then you get the current working directory. And if you want the files inside that current working directory, you just list those files, okay, and you have all those files. Okay, so let's test it right here. Import OS. Import OS. Let's go print OS. Exactly. Get the current working directory and print also OS list directory. And what it does is, okay, get the current working directory and get all the files in there. Exactly. So run those two lines whenever you have a cannot be found. When the file cannot be found, if your file is not on the list, either move it into that folder or give the full path to that file. In Colab, you click the folder icon on the left, okay, it's on the same place and upload it there. On PyCharm, you put the file on the same folder as your Python script or your Python notebook, which is right here. You put your file in there, and then you can continue working. File input. Python has a file you have to open in a certain mode. You have at least three. You have the read. The file must already exist. You have the write. It creates the file and erases it if it already exists. Okay. And append. If you have a file with one name, it appends at the end of the file. It writes what you wrote on the file. Here we have two options. You can create this manually and add right here. In this case, for us to be all the same, to make it easier, we just create this file, and with open data txt we write as a file, and then file we give the order to write this data, and then if it is successful it prints this instruction. On PyCharm or Colab, if you want to do it manually, you do it and then you put the file right here. So let's start with this data. And then we can start at the top. 24, Bob 31, this will be their age, Charlie 19, and Diana 27. Okay, this will be our file, we can put it there. And then we continue with open. W to write, this would be the name of our file. Okay, this can be a little bit tricky because we are creating twice the same file, but it's not a problem. Has been created and saved. And let's do it. txt has been created and saved. By the end we see how can we examine this. Open the file in read mode. We just go here we open this file in read mode. We attribute to this file. We read the contents. Okay, we save these contents as content. We close the file. Okay, and then we print content. There are a couple of things important here, but let's first see if it works. This is one way to do it. And we will see right away another way. To do this. Then file. And then we print the content that we saved above. And let's check if it works. It works. Forgetting to file close is easy to forget, and an unclosed file can lose data if there is an error somewhere. If it gives an error, it stops working, and you forgot to close, then the file, you can lose this data. This is why Python opens the with block, which we used above and we will start using now. It closes the file for you automatically, even if the error happens. With will always be used from here on. Let's now use NumPy as NP. We use NumPy to read numerical data from a text file. This works when the file contains only numbers. Okay, we'll see about this in a second, in a minute. First, let's quickly create a text file with numerical data. This pretends we already have the data file. So numerical data, this will be the numerical data. And then with open numbers txt, we write this file. Okay, this data on a file. And then we use np.loadtxt to load this data. and then we print it. You saw that you entered numerical data. Okay, you entered strings. It converted not only to numerical data but to floating point numbers. So np.txt assumes every value in a file is a number. If it is, it converts into a floating point numbers. Even if one value is not a number, load.txt raises an error. So let's do it right here. Import numpy as np numeric data. We'll do it 1, 2, 3, 4, 5, 6, 7, 8, 9. Can keep the other there. No, I don't want this, but I want another one. Okay, and now we will create our file numbers.txt. Wait a minute. A lot of suggestions there. Okay. Numeric data, it's okay. Then data np load txt numbers.txt, and then we print the data, and let's see if it works. And it worked beautifully. Very nice. Now we will use pandas. It's just an example. We will have a lesson just for pandas, and probably in the future we'll dedicate more and more to pandas, which is really the library that we use to open datasets, all types of files. So import pandas SPD, reading CSV files, Excel files saved as, comma, separated file, separated variables. Using pandas, you might need to install pandas. First, create a CSV file using Python. We have here CSV data, okay, already separated by commas. And then here we use points for the decimals. Some countries have commas for the decimals, and then this creates a problem separating. You have to separate, for example, the numbers with this, okay, but this is what we have here, so it's all right. This is what points, what pandas expects to for the decimal points, and this is what pandas expects to separate every column. With open temperature CSV, we'll write this file, we'll write this data into this file, okay, and then it has been created if it is successful. And then in the end, we read the CSV file with the pandas and we print. So let's try it right here. Okay, now we import pandas SPD, the nomenclature, the simple nomenclature that everyone uses to refer to pandas. CSV data. Okay, it's raising something. Month, day, temperature. No, I don't want humidity. April 1, 24.5. April 2, 25.6. April 3, 25.8. April for 26.0, and then it's all right. Okay. It should be okay. With open temperature as file, CSV data, it's alright, and print data point CSV has been created and saved. And then now we read this data frame. We'll get into these details on the pandas lesson. CSV. And we print this data frame. And let's see if it works. And it works beautifully. Okay. We have the month, the day, the temperature, a comma separated file, and then the points for the decimals. Writing files, the file output. A result that exists only inside a notebook disappears when you close it. Okay. To keep it, we have to write it into a file. Okay. This is especially important in Colab notebooks. Okay. But if you don't save that result, it doesn't exist anymore. It's right here. And to have that result, you would have to run everything again. Okay. So we want to save it into a file. We have already been writing files since section 3.3. That's what writing does. Now let's do it on purpose and save as a result. Because in the previous section we wanted basically a reading, and now we want to save. So, data frame, reading and writing Excel files. You might need to install the OpenPy Excel package. Okay, if it isn't already, you can install it right here. Search it for it right here. Let's OpenPy Excel. It's installed. Oh, you already know what to do from the previous lessons. You use pip install in Colab to install this package. We already have data frame df from the previous cell. Saving it as an Excel file is this one line. You have this data frame to Excel, tempered index false, because if you put it through, it will add one row just with the number, with the row numbers. It will add one column with the row numbers. We can see what it does. Print, if it was successful, it will print this. Reading it back in one line. Okay, this is, then we wanted to show this, and then we read Excel again and we print the result, and we'll see this at the end. So data frame point to Excel, temperature Excel, index. Let's put it through for us to see the difference. Okay. Print has been created and saved, and df Excel. The new name of this data frame will be df_Excel, and we'll use pandas, and from that pandas we'll use read Excel temperature Excel as X. So, and then we print everything. Okay, so we see that we really don't need, if you put this index as true, we have an extra column, let's say like this, with the number of the rows, and we don't need it. If we put it to false, it will give this result. Let's put it false right here. And it disappears. And now, to confirm that the file has been created, we import os, print this question here, os path exists, and it checks if this file exists and gives a true or false. Then the files in the folder, you can, from the OS library, you can list everything in the directory, and you have every file. So temperature Excel exists, true, and then temperature Excel exists, SX, it's here, okay, within the other files, and we can check, and we check that it's here, and the previous ones too. Let's just code it this to confirm, to practice. So import OS, print temperature has been temperature X exists, comma, and then this instruction. Exactly. It should be true, exactly, because it exists. And now let's see everything there. OS, everything that I have. Okay, it's everything we have, and temperature XLSX, it exists right here. So I think it was a very cool lesson, okay, about inputs and outputs, and we'll see now matplotlib for processing, we'll see pandas for processing, and then scikit-learn for processing for building machine learning models. So thank you very much, and see you on the next lesson.